Hello everyone. So today let's talk about how you can simulate a Bluetooth low energy network in MATLAB. In this video, I will only talk about the basic framework of how you can build a two-node network in MATLAB and introduce the functions required and their roles. In the following videos, we can discuss these functions in detail and take a deep dive into how you can set the different parameters to make the simulations closer to your network. In this series, I will assume that you are familiar with the basics of Bluetooth Low Energy Protocol and won't deep dive into the details related to the protocol itself. If you want me to teach the basics of BLE as well, do let me know using your comments. So now let's get started with the code. Keep things as simple as possible in this first example. I will start with how you can simulate a non-connectable Bluetooth Low Energy system. In the non-connectable mode, a Bluetooth device will simply transmit its message without caring whether or not it was received successfully by the receiver or the scanner device. This mode of operation is also popularly known as broadcasting mode in BLE. In the first section of the code, I have initialized the wireless network simulator, and this statement needs to be there at the start of all your wireless communication. And one other important point to note here is that you will also need access to MATLAB communication toolbox along with MATLAB Bluetooth toolbox to simulate any BLE network. In line 3 of the code, I have initialized the simulation time parameter which needs to be passed to run function later. In the second section, I have created a Bluetooth low energy node using the Bluetooth LE node function of MATLAB. And this command here ensures that the nodes created work on BLE protocol. We need to assign a role to the device as well, that is whether it will act as an observer or it will be transmitting the packet as a broadcaster. I will talk about this function in detail in a later video, but what you need to know is that these functions need multiple input parameters for functioning properly. And these parameters are initialized to a default value which can be seen by going inside the function definition. On line number 7, I have set the location of the device in XYZ coordinate system. So now let's go and run the first two sections and look at the workspace window. In the workspace window, you see that an object named observer node is created. So now simply we need to access the member inside it and initialize them as well as use them to build algorithms. It's a bit like how we access structure members in the C programming language. So now let me take you inside the observer node parameter. All these parameters can be set like the position parameter we had set, and currently they are initialized to a default value. So if you see this transmitter power function or property, we never set it in the code, but it is initialized to 20, which is the default value in MATLAB. Similarly, the range parameter is 100. These values are currently way off than what we normally observe in BLE SOC, and looks like made a mistake in the name here. So let's go back and correct that first. There was a extra in the observer node name. Now let's run this section again and go inside and check that. So now the name is corrected. So coming back to our code, in this next section, I have similarly defined a broadcaster node which will be transmitting the packets. On line number 9, I have used the Bluetooth LE function again, and inside it, I have assigned the role as broadcaster. And this makes all the difference and decide which part of BLE stack will this node be installed with. On line 10, I have assigned the name to the device, and on line 11, the position is defined. Coming to how I knew what inputs we can give to Bluetooth LE node function. There are two ways to know that. The first one is to right click on Bluetooth LE node function and it takes you inside the function definition where you can look at its properties. So I have highlighted the role part here. You can see it can be one either of the observer, broadcaster, central, peripheral, etc. Or you can also type Bluetooth LE node, help Bluetooth LE node in command window, and it will display the important properties related to this function. So if you see on the second paragraph, the role specifies similarly to the previous one. So now let's run this section and create a broadcaster node for the observer to listen to. In this next section, I have created a network traffic on-off object. In wireless communication, network traffic means transmission of data packets, and since here we are talking about on and off state, so the model will generate packets with a fixed interval only during the on time. In the off state, no packets will be produced. The data rate here is defined in kbps and the packet size is defined in bytes. On line number 17, I have used add traffic source function. This function will attach the generated network traffic to the broadcaster node. And since it is a non-connectable mode or broadcasting type of mode, we haven't specified any destination node here. In connectable mode simulation, we would add a destination node parameter as well at the end. In this next section, I have created an array named nodes, and all the nodes which needs to be part of the system or the BLE devices which you want to be the part of system needs to be added to this array. And then these nodes are passed to the simulator using the add node functions. So now the network simulator has all the information about nodes that are part of the system, and nodes also know their role and specification. In this section, on the line number 22 here, I have created or instructed the network simulator to run for the simulation time parameter which we had specified earlier. On line number 23 and 24, I've used the statistic function on observer node as well as the broadcaster node. So this function will return the results like latency, throughput, and number of packet transmitted and received by nodes. And the results are presented separately for each layer, that is physical layer, link layer, and application layer. Now let's run the entire example, but before that, let's clear the command window with CLC. The code will take some uh, time to run since we have set the simulation time quite high. And this in general will increase as we keep on increasing the number of nodes in the system. So it is better to keep the simulation time variable to a small value. So now both the stats for the observer and the broadcaster nodes are calculated. And if I open this, you can see that it is splitted in the layered form. So for example, if I want to see the result for the application layer of the peripheral device or the broadcaster node, I can click on this app field and it will showcase the relevant information like number of packet transmitted. And since it is a broadcasting node, the received packet for it should have been 0. Similarly, for the observer node, it should only be receiving the packet and transmitted packet should be 0. So now, yeah, you can see it is 0 in fact. And this concludes our topic for today's discussion. Thanks for watching this video and leave your comments for any suggestions and improvements. Also, to learn more about the basics of MATLAB and different windows in MATLAB like workspace, editor, command window, you can access the basics of MATLAB playlist in my channel.